Okay, so now we're going to look at the last two exercises. The first one is to wind 3 wires. So you can see I have 3 wound in the counterclockwise direction. And so I'm going to wind one in the clockwise direction. So now I have one in the clockwise direction. And steady this so that the compass is again at 0. And so pay attention to the compass when I apply the current through the 3 loops going counterclockwise and 1 loop going clockwise. So when I apply current, and as you can see I apply 1 amp of current, it goes to roughly 30 degrees if you can't make out the numbers on the compass. So before, when we had 4 loops, as you can see from the data, we got into the 50s. And so what's going on here to make it not deflect as much even though there are 4 loops? And that comes down to the right-hand rule. For the wires going counterclockwise, we have current going this way. And so when we do the right-hand rule, our field is going to deflect towards the edge of the table or towards the way my fingers are pointing. When we add the loop going in the opposite direction, the current goes in the opposite direction, and the field it adds is going to go away from the camera or towards my table, towards the way my fingers are going. So inside the loop, it's going to point in this direction. Inside the loop for the other 3, they're going to point in this direction. And so when you add vectors of magnetic field, you're going to get 2 that cancel out, and you're going to end up with a net of essentially 2 loops, because 1 counterclockwise loop is going to be canceled out by the 1 clockwise loop. So think about that and make predictions for what you think is going to happen when we have 2 loops going counterclockwise and 2 loops going clockwise. So think about that while I set that up, and I will record that as soon as I'm ready.